Hello, this is module 2, single area OSPF version 2 configurations. It's a continuation of the other module 1. But this time we're going to go deeper to look into how to configure OSPF, or how to throw in the settings, settings of open shortest path first routing protocol, both for single area and then multi area domain. So the objectives, or the module objective is to implement single OSPF area, but of course we're going to look at even multi area in both point-to-point and then what you call broadcast access, where we need more routers interconnected with maybe Ethernet. So we're going to look at what we call OSPF router ID point-to-point OSPF mulch, and then modify single default route propagation, and then we verify single area OSPF version 2. So let's begin with OSPF router ID. So this is the topology that you are going to keep on referencing to. So as you can see, even it is a OSPF reference topology. That whatever that you're going to go through, all these other slides, the coming slides, they will be pointing back to this reference topology. So when you look at this router 1, it has a 1, 2, 3 interface. This is a loopback interface. This is a loopback interface. It's a loopback interface, this one here, and then these are physical interfaces. This, and then this interface. But this is a loopback, even this is a loopback, and then this is also a loopback. So this loopback, it is assimilating the internet connection, ISP. And then we have this, but all this, when you look at this from this, then back out, they are in area 0. So we're going to keep on referencing to this or this topology. So router configuration mode of OSPF, router configuration mode for OSPF. Of course, you have to access global configuration mode and run this command. It's router OSPF, but of course you have to put the process ID. That's the reason why we have a 10. So in this mode, after executing this command, then the mode is going to change to configure router configuration mode, which is this. And in this mode, these are the commands that we can actually, the possible values are the commands that we can execute: the area, autocost, all this, and up to router ID. Router ID. An OSPF router ID is a 32-bit value represented as an IPv4 address. It is used to uniquely identify OSPF router, and all OSPF packets include router ID of the originating router. So it is used to uniquely identify OSPF router, and all OSPF packets, including router ID of the originating router. So every router requires a router ID to participate in OSPF domain. So it can be defined by administrator or automatically assigned by the router. So participate in synchronized. Why would we need the router ID? Why do we need the router ID? So it participates in the synchronization of OSPF database that the OSPF database, if it is to be synchronized with other the neighboring routers, of course, the router ID has to be used to uniquely identify the database. Participate in election of designated router to see which one should be the reference router. That in case there is a change, in case there is a change on a specific, on a certain router, then the router so this is module 2, yeah, so 2 single area OSPF configuration, and these are the areas to, these are the topic titles or the areas to cover on this, then uh, this on this slide, in this slide, these are really, it has the OSPF reference topology. So all these other coming slides, they will be pointing back to this reference topology. So whatever that you're going to cover, it will be pointing back to this slide. So, excuse me. On this the router configuration mode for OSPF, we have to use this command router OSPF in global configuration mode, and then once you execute that, it takes you to this mode. So this mode, it is configuration mode or router configuration mode, and all these are possible commands that they can be executed within this mode. So router ID, it is a 32-bit value represented in IPv4 address. It is used, you can state it as 192.168.1.1, something like this. But do not put the subnet mask. It is used to uniquely identify the OSPF router and all OSPF packets, including router ID of the originating group. So every router requires the router ID to participate in OSPF domain. So why do we need the router ID? It is used by an OSPF-enabled router to do the following: participate in synchronization of database. The database to be synchronized with the neighbors, it has to have the router ID that uniquely identifies that database. Participating in election of designated router, So the designated router, it is always a referencing router that all these other, when there is a change, the router that is facing or that is interfering with the change, it communicates to the designated router, and then designated router, it broadcasts the updates to all these other routers. Router ID order of precedence, because we say it can be set automatically, auto, then or manually. So once you use router ID, you're trying to set it manually. But if you don't deal with router ID, then it means that the router, it will use automatically select its router ID. So Cisco router derive the router ID based on one of three criteria in the following preferential order. So the first one, the router is configured using router ID. So once you state this command, then it means that you're forcing it. You're dictating which value to pay as the router ID. Then the router chooses the highest. If this is not set, then the router will choose the highest IP address of any configured loopback. So on a router, in case let's say you have a loopback interface, then automatically the loopback interface with If it's 1, then it's okay. That one is going to be taken automatically. But if there are 2, they are going to be compared. The one with the highest IP. So in case, let's say we have 192.168.1.2, and then we have another one as 192.1.1, maybe .10. Automatically, this one here, it will take over because it is the highest compared to this. So the router chooses the highest active. In case, let's say, these two are not available, then the router, of course, this one here, it's a sure deal. It's obvious that the router has to be assigned with any IP address, normal IP address. So the router chooses the highest active IPv4 address of any of its physical interface. So configure loopback interface as the router ID. Of course, you don't need to do dot. All you need is just to be in global configuration mode, and then you call the interface loopback 1. And then this, in case, let's say it's just one interface, if it's just a single interface on that very router, for example, let's assume that we have this router, we have that router connected to this other router, and then we have our loopback, this. So this one here, it's going to be used as the router ID. But in case there are 2, then now loopback, this is 0, 1. Now automatically loopback 1 and then loopback 2. So if there are 2, then this one here, it's the highest. It's going to want to check over. So explicitly configure a router ID. In our reference topology, you remember the reference topology. Let me try to bring it back so that you're able to look at it. This is our reference topology. So you see that we have on router 1, it is this. The router ID, it is 11. On router 2, router ID it is, because they are not indicated here, but what we have there, they are loopback. So we have this as the loopback. We have this as the loopback, as you can see. We have this as the loopback. These are 2 actually, and then we have this, all that. So so when it comes to the router ID, we have 11 on router 1, 22 on router 2, 33 on router, then 3. So here, as you can see, we have just screenshot of the command. So it's router OSPF10. Then you can go ahead and now assign. We want to assign the router ID manually. So this is 1 router ID, then 111 router, then end. So if you try to show IP protocol, include router ID, as you can see it is here. So we can redo this for the 3 routers, even router 2 and router 3, but changing the router ID from 1 now. This time on router 2 it will be 22, on router 3 it will be 33. So modify router ID. After a router selects ID, an active OSPF router does not allow the router ID to be changed until the router is reloaded or the OSPF process is reset. So for example, in the first place, remember we had loopback, then we have the highest IPv4 address, that if this one here is not the, it has to be router ID, then loopback, and then IPv4. So in the first, this. So if this is not active, then router back interface comes in. If not, then this one here. So the moment it picks something as the router ID, so it will not release that until the router is restarted or the process ID is reset. So here in this, as you can see, we have the router ID on router 1. The router ID, it is 10.10.1. 10.10.1, and then after configuring, as you can see, we have this one here, router, OSPF this, then router ID, and then N. So you have to clear the IP process, IP OSPF process, so that it can pick this. As you can see, it's this, so that it can pick this one here. So after clearing IP OSPF process, these are the steps. Then there you will, or the router will be able to pick one as the router ID. So on point-to-point OSPF network, you can specify interface that belongs to point-to-point network by configuring the network command. You can also configure OSPF directly on an interface using IP OSPF command. So the syntax, if you're to ask to enable OSPF, there are two methods. There are two methods where you have to be in router configuration mode, and then you put network, and then with the network you specify a network together with wildcard mask, and then the area. So I'm going to show you that. So the network address wildcard mask syntax is used to enable OSPF interface. Any interface on the router that matches this part of the command are enabled to send and receive OSPF packets. So the area command and area ID syntax refers to area, the domain, like the group. When configuring single area OSPF version 2, the network command must be configured with the same area ID value on all routers. What we saw in the reference topology. So although any area ID can be used, it is good practice to use an area ID of 0 with a single area. So most of the time when you're dealing with single area, it is advisable to use area 0, not to use area 1. But you can use area 1 in conjunction with backbone, and the backbone, it is always a 0. It is always a 0. The wildcard mask is typically the inverse of subnet mask. So if we have subnet mask as 255.255.255, then dot 0. So for you to get the subnet mask, you will actually get the 255/55/, and then you subtract your new subnet mask, which is 255.255, then dot 0. So here it is 0, then 0, then 0, and then this is 255. In other words, because they are saying inverse. So if in case, let's say we have watch, I want to work and write. Okay, so let's assume that we have 255, then dot 0, dot 0. So the inverse, here it will be 0, 0, then 255, then 255. So this is the inverse. And there are those scenarios where you'll have maybe if it is slash what? /27, /27, there is 8 ones, 8 ones, 8 ones, to 24. Then to 27, 1, 2, 3. Then the rest are 5. They are zeros. So here you will flip. Here there are 8 ones. There will be 8 0, 8 0, 8 0. Then here we flip again. We are flipping. This is going to be 0 here, 0, then 0. This is 1, 1, 1, 1, 1. So you convert this. So this is 224, then it means that the other one it is. If it's 224, then this one here it will be 31. So this one here, for this one here, it will be just this, because this one here it is 255, 255, then 255, then dot 224. So the reverse here it will be 0, 0, 0, then 31. 31. So if you add this, if you're to add, you should get the total of 255, 255. This is the way of proving. So this is 224, and then if you add this, it gives you 255. So in other words, all you need is just whatever the subnet mask you have, subtract it on the complete 255, 255 throughout. So that is the wildcard mask. So when you look at what we have here, what we have here, that this is our subnet mask. This actually this is supposed to be a 0. That if you subtract this 0, 0, 0, and then you get to this. This is slash 26. Slash 26, it means that this is 196. This 192, and it gives, if it's 192, then this one it gives us a 63. This a 63. So please use that concept, and then you try to see whether you will be able to get the wildcard mask, that concept of wildcard mask. So within routing configuration mode, there are two ways to identify interface that will participate in OSPF version 2 routing process. In the first example, the wildcard mask identifies the interface based on the network address. Any active interface that is configured with excuse me, any active interface that is configured with IP address belonging to that network will participate in this. Note, some iOS version allows subnet mask to be entered instead of wildcard mask. That in those some scenarios, you will be allowed to enter subnet mask instead of wildcard mask. So it is in this format that you will just run router OSPF, then 10, then network. As you can see, this is the network, then wildcard mask. This is the network, which is this, then the wildcard mask, and then the area. This is the wildcard mask, and then the area. Then we have other, this other alternative can be a specific, specifying the exact interface. Specifying exact interface. So with this exact interface, we're going to deal with, because if you deal with the IP addresses, they won't be allowed. Instead of IP, this is router OSPF10. Instead of a group like what we had here, this is a group that within this one here we expect include this 255 IP address inclusive, including this inclusive. This. So 200 and this. Then when it comes to this network here, as you can see, that it is allowing, actually this one here, it's the first one, and then these three, totaling to 4 addresses, and then this also totaling to 4 addresses. But when it comes to this one here, we have wildcard mask of 000 now, meaning that it's only these IP addresses, the stated addresses. The rest of the addresses, they won't be allowed to participate in sending and receiving OSPF packets. So configuring, then we have what you call configure OSPF using IP OSPF command. Remember, you can use network. Now, if you use network, you can allow actually use the previous method that we've looked at. But now this one here is to use IP OSPF command. So this one here, it has to be done. That one was under router configure OSPF router OSPF configuration mode. But now this one here, it's under interface, meaning you have to do the advertisement under the interface. So we can actually, with this one here, it's the same router, but we have to first remove this. That is router OSPF 10, and then we remove the previous configuration, which is this. We're removing, that's the reason why they're starting with no. And then after that, you go to the interface, which is interface gigabit Ethernet, this, and then you put IP OSPF10 area 0. You go to another interface, which is this IP OSPF10 area this. So we don't need to know the networks like what we were doing in the previous method. So here all we need the interface that are participating in the OSPF, router OSPF. Even here we have the loopback, as you can see, it is this. So we're actually adding the interfaces, not the network. Of course, once you add the interface, whichever network that is attached to that network, it will be part of the OSPF. So we have what we call the passive interface. Passive interface. So a passive interface, it will not allow, it will not PF packets, it will not allow OSPF be received or sent on that interface. So sending out unneeded, because those passive interface, if they are sent on the interface where they are not needed, then they will end up actually being or categorized as unnecessary packets. So sending out unneeded messages on a LAN, it affects the network in three ways. One, inefficient use of bandwidth, that bandwidth is going to be consumed by these unneeded messages. Then inefficient use of resources. Yeah, it's they are resources intensive, that every time that interface receives that unneeded message, it's going to be processed, it's going to be stored, all that, competing with needed messages. Then increased security risk. So those unneeded messages, they will end up causing security states, called security threats. So to configure passive interface, here you will have to be in the router, the mode. So that's the reason we are coding it here. And then passive interface loopback. So this interface, it's not supposed to receive. It's not supposed to receive. So once you're there, router OSPF10, now passive interface, you specify that interface that to be passive, something that is passive, it means that it cannot receive or send. Mostly receiving, we're aiming at receiving. It wants to receive OSPF packets, see? And then end. After that, you can run the command to prove or to verify. Show IP protocols. As you can see, this is the process ID, OSPF process ID. It's this, maximum this. Then the routing interface in configuration explicit, the interfaces in area 0. We have loopback, we have this 1 and then 0. Then passive interface, we only have 1. Then we have the routing information source, the gateway. So as you can see, the neighbor, because this is router 1. Now the neighbors, they are identified by router ID. We have 33 and then 3, 33 and then 2, 2. OSPF point-to-point network. By default, Cisco router elects DR and BDR on Ethernet interface. So even if there is only one other device on the link, so you can verify this with show IP OSPF interface command. So the DR or BDR election process is unnecessary as there can only be 2 routers. So in that process of where there are 2 routers, we don't need the DR and BDR. Automatically one has to be DR and then the other one BDR, but we won't get the BDR. So notice, so in that now, so unnecessary the router to be output that router has designated and then the network type, which is this. After running this command, show IP OSPF interface, interface gigabit Ethernet 00, we have the internet address as this, this the area, it is this. We're dealing with this is the IP address on this. And then attached we have this enable process ID 10 router ID, as you can. The network type, it's a broadcast. The broadcast, it means that you cannot say that into router that it's a broadcast network type. No, and it has to be under multi broadcast multi access network. network. So here it is. So this A2 is a designated route. Here it's a broadcast. It is a point to point. But again, here when you look at this, that a 2-2 designated router, it's a 2-2, um, 2-2, and then the backup is 1, 1, designated. So this is designated router. Now here, remember it's a point to point. We have router, then router 2. So in this, since we have DR and a 2 here, it's the one to be the designated because it has the highest router ID. And then this, so this it has to be because it's point to point, though we have another network. This side as router 3. So it will be on this since the network, it is the network type, it have to be the designated. When you look at it, designated router, it's a 2. Backup, it's on this. That is between R1 and R2. On R3, this it will be designated and then this backup. Come on this, it will be designated, then this backup. It comes to this one here, the designated will be this 3 and then this as a backup because it is a point to point. So to change this point-to-point network, use the interface configuration command IP-OSPF network point-to-point from broadcast. So you call the interface, as you can see, it is this one here, this interface, and then IP-OSPF network point-to-point. Then once you try to try again, this time instead of network type broadcast, we have point-to-point, and this time we don't have the backup and then designated. The designated router and then backup designated. So loopbacks and then point-to-point interface. Use loopbacks to provide additional interface. So the loopback is for extra in case let's say you are in need of extra interfaces. You can use loopback interfaces for a variety of purpose. By default, loopback interface are advertised as 32 host route. So to assimilate real LAN, the loopback interface can be configured as point-to-point still. Yeah? Can be configured as point-to-point to advertise full network. So what router 2 says, what router 2 says when router 1 advertises loopback interface is interface is. So this is show on router 2. This route, as you can see, you see this one here, this router 2, but you are seeing this as network, which is 1, this 6. So which network? Let me try to bring in our reference. So where is our 10.10.1.0? This is R2. So this is R2, 10.10.1.0.2. So it is this. It is this one here. This the loopback on R1. So when it comes to configuration change on R1, we shall actually, as you can you call the interface, then the OSPF point to point, so that this is also a point to point, so that it is a point. It is a point, point to point. Yeah, that is it. Packet tracer point-to-point single area OSPF configuration. I will give you this packet tracer configure network type, this IP OSPF, then the passive verify the operation. Then multi-access or OSPF network. Now, as you can see here, we expect multiple routers connected by switch. So once we have a switch, then automatically the network type is going to change from point to point. This one here, it's not point to point, it's a broadcast. That if this one here communicates, it's likely to router 1 to receive, router 3 to receive, and router 2 to also receive. So OSPF designated router in multi-access network, OSPF erects DR and BDR. these routers to send a broadcast. But these other routers, for them, they have to communicate to DR one-to-one, one-to-one. But DR, for it can send a broadcast. In doing that, the network design, it will actually eliminate or try to reduce on the unneeded messages. When there is a change, that router where the change has occurred, it's the one to communicate to only DR. And then DR will communicate to these other routers. So that is the logic. So still, in the multi-access topology shown in the figure, there are three routers, as you can see, interconnected over common Ethernet multi-access network. And the network, it is this. Because the routers are connected over a common multi-access network, which is a switch, OSPF has automatically elected DR and BDR. R3 has been elected as DR because the router ID, it has the highest router ID, which is, yes, so router 2 is the BDR because it has the second highest router ID. So this is the DR. In case, let's say there is a change, an update somewhere here. So this computer, it will contact the DR, which is this, and then the DR here, it's the one to communicate to this. But not this one here to communicate here and then this. Even when there is a change here, this communicates this and then this. So there will be that confusion. So verifying OSPF router roles. Are you going to verify the roles? By running this command. So remember there are three routers. So we are on router 1. So if there are three routers, if you're on router 1 and run show IP OSPF interface gigabit this, then we shall actually look at the address, which is this, the area, which is this, the process ID, which is 10, router ID, as it's 1. Then automatically, when it comes to the transmit delay is 1 second stage. Now the state here, the state of this router, you can say the state of this router, it's DR. It's DR others, and the priority it is 1, meaning that this one here, it's designated router, nor the backup designated router. But we should have actually the backup and designated. So when you look at this, the 2 among the 3, 2 is the backup, and then the 3 is the designated router. So when it comes to router 2, still the same command, which is this one here, the state. Now this one here, it is the BDR, or backup designated router. The priority, it is 1, meaning that the priority, they have the same priority. And then the designated router, it is 3. And then when it comes to the backup designated router, it is 2. We are not synced. Then when it comes to this one here, adjacent with this, the neighbors of R2, it's this and then this. Now we are not seeing the one, the role of one, the state of one. It's not anywhere because it's DR others. So these DR others, they will always connect to try to contact the designated router. This is R3, the same scenario. The same scenario. As you can see, the process ID is this, it's router ID is this, the network type it's broadcast. Then when it comes to the designated router, it is 3, the backup it's this. Then the neighbor count, as you can see, the neighbor count, there are 2. And when you look at this, you have 1, and then 2. This is router 1, this is router 2, and this is router 3 where we are. And the state, when you look at the state, it's the native router and then the priority is 1, meaning that all the 3 routers, they have the same, all the 3 routers they do have the same, priority number.